All right, here we go. So we're learning how to solve rational equations, solve them graphically, and solve them algebraically, or sometimes they call that analytically. I'm not sure what the difference between those two words is. I'll have to ask one of my um, solid community college colleagues. Okay, so let's look at a couple of examples here. Solve each of the following equations graphically and algebraically. Now I printed out my notes from previous years so I could follow along, and my cat just came and laid on them, so I just pulled them out for him under my black cat. He's just sitting here wondering why I'm talking. Maybe he thinks I'm talking to him. Who knows? Okay, so we've got example 1, and 2x minus 1 over x plus 3 equals 0. We are solving each of these equations graphically and algebraically. So to solve it graphically, what we're going to do, we're looking at where, oops, I don't know what my pen just did. We're looking at where it equals 0. So that would be where the graph intersects the x-axis. I don't know if you remember that from solving other equations, but the points where, if an equation is equal to 0, then the points where that equation crosses the x-axis would be the solutions. Okay, so let's go ahead and graph this, which we've wanted to do the last few days, over the last week or so. So one thing I've already got my asymptotes in here. Let's talk about what those are. So we've got an asymptote at -3 because of the x plus 3 in the denominator. And then we have an asymptote at y equals 2 because the degrees in the numerator and denominator are the same. And so the leading coefficients would be 2 divided by 1, which equals 2. So we've got our y equals 2 here and our x equals -3 here. And then our graph, we can throw some points in there to figure out where our graph would be located. So let's just take our numerator, remember, would give us our x-axis, or x-intercept, right? So 2x minus 1 equals 0, so 2x equals 1, and x will equal 1/2. So that means that we should have a point at 0, 1/2, 0, where x equals 1/2 and y equals 0. So the graph must go through this corner here, and this corner here. The whole point of what we're trying to accomplish here is figure out where this graph equals 0, and that's what we just found. We just found it at 1/2. So the solution to this equation is x equals 1/2. Any questions on that one? Okay, let's do the other one. Now this one, instead of it being equal to 0, it's equal to 4. Notice how we've got the same exact graph, so I can just throw that in there more or less. But instead of us solving it by trying to figure out what point is going through 0, y equals 0, we're going to figure out based on where the point goes through y equals 4. So you can probably see I've already got this blue line here at y equals 4, because wherever our graph crosses that line, that would be the solution. We've got about the same graph going on here. Now this bottom part that goes through here isn't going to matter as much this time because that's never going to cross through our line y equals 4. So the important part of this problem is figuring out where the red branch of our graph crosses the line y equals 4. Let's do that by just cross multiplying. So I'm going to put this side of our problem over 1 so I can cross multiply the two parts of my equation. So 1 times 2x minus 1 is just 2x minus 1. And then 4 times x plus 3 would be 4x plus 12. Notice how I distributed the 4 through the entire thing, right? Now I just have a linear equation that I need to solve. So let's get the x's on one side and the numbers on the other side. If I subtract my 2x here and subtract 13, this isn't writing as easily as it does when I write on my smartboard, but Okay, I suppose. So that gives us 2x equals, so we had a -1 and we subtracted, why did I write a 13? It should be a 12. That's because it's going to add up to a -13. So -1 and -12 is -13. So that gives us, divide both sides by 2, we have x equals -13/2 or -6.5. So look at this graphically. I know I wasn't very careful about where I plopped my graph. So theoretically though, because I just solved this way, the point right here where these cross should be at -4, no, -6.5, so 4, 5, 6.5, so more like right there, and then up to that 4. So obviously my graph is not really sitting in the right place. I wonder if this will just let me grab it and move it. So the graph we're looking at is more like this. Probably this branch over here would be more symmetric than it looks. And I'm just making it messy. But the idea behind this is we're trying to see how this solution applies both graphically and algebraically to show that it's the same solution either way. Okay, I feel like I'm rambling, and maybe that's just a symptom of me just feeling like I'm in this bit of a cloud. My husband calls it the COVID cloud. So I'm mostly feeling okay, but a little bit out of it. Okay,